Today we're going to start talking about domain and range. Domain is all the possible x values that a relationship or a function can have. And range is all of the possible y values that that function or relationship can have. So before we get into the actual domain and range stuff, I want to go over a couple of things first. All right. I want to talk about Dixie, and Roy D. All right. Dixie, and we talked about this last week when we first started talking about functions, but Dixie is another way to help you remember all the different terms that could stand for X. So the D would stand for domain. The I is for input. The X is for the x-axis or the x values, and I is for independent variable. Dependent. All right, so Dixie, if you take the first letter from each one of those, we get Dixie. Domain, input, x-axis, independent variable. For Roy D, that's just going to be the opposite of each one of those. So the opposite of domain, zoom out of here a little bit so we can see them all at the same time. The opposite of domain is the range. Okay. The opposite of input is output. The opposite of the x-axis would be the y-axis. And the opposite of the independent variable would be the dependent variable. So Dixie, domain, input, x-axis, independent variable. Roy D, range, output, y-axis, dependent variable. These things are all interchangeable. Okay, I can use any one of these to be talking about the x value. And I can use any one of these to be talking about the y value. So today, we're going to concentrate on finding the domain and the range of discrete functions and relations. First, I want to start with a set of ordered pairs. Set of ordered pairs, we just have a certain amount of numbers. And all you want to do is list the x and the y values for each one, for the domain and for the range. So, for the domain, I'm going to take all of my x values. The x values are the first number in the set of ordered pairs. So the first number in the parentheses, each one of those is my x. So I can see I have a 2, a 3, a 4, and a 4. All right. Since the 4 repeats, I don't need to write it down twice. I only need to write it down once, because it doesn't matter how many 4s there are. That's going to be that just writing it down once tells me that there's a 4 in the domain. That 4 can be an x number. Doesn't mean that it's only an x number once. It just means it's one of the x numbers. So for my domain, I could write that it's 2, 3, and 4. All right. It's a good idea to list them in order, not of how they appear, but in order from the smallest number to the biggest number. And then I'm going to put them in brackets, because that's how we show domain and range. So my domain for this particular set of ordered pairs is 2, 3, 4. Now let's do the range. So the range is the y values. That's going to be the second number in the ordered pair. And I have 1, 0, 2, and -2. So again, since those are all different, I'm going to list all 4. And I'm going to put them from the smallest number to the biggest number. So the smallest number would be the negative, then 0, then +1, +2. Put those into the little bracket things, and now I have my domain and my range for this particular relationship. Is this relationship a function? I'll give you guys 10 seconds to think about that. So what'd you come up with? Is this a function? Why? Why is it not a function? Fantastic job. You guys are super smart. All right, let's move over to our table. So we have a table of values. And again, in order to find the domain and range, we're just going to list the x and the y values. On a table, it's a little easier because all the x values are already bunched together. So for the domain, which is going to be our x values, we're just going to write them in number order, starting from the smallest number to the biggest number. So I got -2, -1, 0, +1, +2. And I want to make sure that I put it in the little bracket things. So this tells me all the possible x values for this relationship. Do the same thing with the range, which is going to be our y values. And again, I'm going to put them in order from the smallest number to the biggest number. Smallest number is going to be down here at -4, or is -4. Then -2, 0, 2, +4. So there's my domain and range for this particular relationship. Again, is this relationship a function? Why or why not? Next, we're going to talk about a mapping. So we have this mapping on your paper. Again, we're just listing the x and the y values. The good thing about a mapping is that mappings already have the x and the number and the y numbers in proper order from biggest to smallest, so all we have to do is just copy them down. So the domain, which is the x, is going to be these numbers right here, and we're just going to copy them the way they're written because they're already in numerical order for us. -2, +3, +4, +10. And then put the little brackets on it, and we've answered that. For the range, I'm going to take all the y values. Again, already in number order, so I'm just going to write them the way they're listed there. -1, 0, 2, 4, 6. And put the little brackets around it. So these are all the possible x values in this particular relationship. As you can see in the mapping, these are all the possible y values, the range. Now, is this relationship a function? Why or why not? Finally, we're going to talk about graphs. So here we have a graph. Now we need to find the domain and range of the graphs. So let's start with the domain. The domain is which value? Correct, it's the x. So I'm going to find all the x values of those dots. I'm going to start from the left to the right. The reason I start at the left is because the smaller numbers will be at the left. So as I'm finding the dots, or what number they are, from left to right, I'll be writing the numbers in order and I won't have to go back and redo it. So this is my first dot. I'm going to draw a line down to the x-axis to show me what that x value is. So this dot, the x value is +1. So for my first domain number, I'm going to write 1. And for this dot is 2. And then the next dot is 3. Doesn't matter that it's below the axis and that the y number is negative. We're not looking at that right now. We're just looking at the x numbers. 3. This one's 4. And then I have 5 on the x-axis. And finally 6. So my domain numbers are 1, 2, 3, 4, 5, and 6. So put it in a bracket. Now, let's find the range. Now the range is the y values. So instead of drawing a line to the x-axis, now I want to draw a line to the y-axis and see what number that is. With the x's, I started at the left because on the x-axis, the smaller numbers are on the left. With the range, I'm going to start at the bottom because the smaller numbers are going from the bottom to the top. So here's my first dot starting from the bottom. Draw a line to the y-axis, and I see that that number is -1. So that's my first range value. This one right here on the x-axis, this y number is what? 0. So 0 is my next number. Then I have this dot, which touches the y-axis at 1. Then this dot touches it at 2. This dot at 3. This dot at 6. So 1, 2, 3, 6 are my range values. So I have found the domain and the range of this graph, right? These are all the possible x values right here, possible x values of this graph. The range, these are all the possible y values that could make up this graph or this relationship. Finally, is this graph a function or not? And tell me why. Yes, this is a function, and this is a function because none of the x values are touching more than one dot. So this vertical line, only one dot. This line, only one dot. One dot, one dot, one dot, one dot. So we have a function. So that is how we find the domain and range when given a set of ordered pairs, a table, a mapping, or a graph.